Hello and welcome! In this lecture we're going to add a zoom ability to our camera controller. Okay, so here's our camera control so far. We can move the camera in any direction and we can also rotate it. So the last thing that we need to handle is the zoom. Now there's actually two ways to zoom a camera. We can test them out by changing some values while the game is running. So let's just get out of maximizing the game view. Let's select the virtual camera and let's look at it. And since we don't want to modify any of these fields, let's make sure we untick save during play. We just want to make some changes to see how they work, but we don't want to save them. So as I was saying, there are two ways to zoom a camera. One method is by lowering the field of view. So the lower it becomes, the more zoomed in the camera is. Another way is on the body, we have the follow offset. So if we get the I and the Z, both of them closer, so get the Z closer, get the Y smaller. There you go, that's another way of doing a zoom in. Or actually the final method, which I prefer, which is the same thing, playing around with the follow offset, except instead of changing both the Z and the Y, now we just change the Y. So lower it or increase it. Now I like this one because as the camera zooms, it's going to be closer and closer to the ground, which also gives a different perspective to the game. So that makes it a bit more dynamic than always having an overhead view. You can keep it nice and overhead by default and then zoom in if you want to get a eye level view. So personally, I really like this method, so let's use this one. Okay, so let's go into our camera controller script, and down here let's add some logic. Now the first thing we need is some input, and for zooming, what makes most sense is using the mouse scroll wheel, so let's handle that. We can easily access that with input.getMouseScrollDelta. Now even though the scroll wheel only has one axis, this one is actually a vector too, so apparently there's some mice out there that scroll on the X, which is a bit odd. But chances are you want to scroll on the Y, that's the most standard. So we can just do a debug.log on this one. So debug.log, print out the scroll delta to see what this returns. So let's see. Okay, so looking at the console, I've got 0, 0. If I push the scroll wheel upwards, there you go, I've got a +1 on the Y. And if I pull it back, I've got -1. Okay, so that's how it works, super simple. So with the mouse scroll delta, we have the scroll wheel input. Now let's try using that to modify the offset Y to zoom in. So this is actually the more complex part of this system due to how the specifics for how Cinemachine works. You might think that we could just access the Cinemachine virtual camera and then somehow directly access this follow offset. However, if we try that, it's going to cause some issues, but let's try. So first in our script, we're going to need to add using Cinemachine. Okay, then let's make a field, make it serialized field so we can set it in the editor. Make it of type Cinemachine virtual camera. Okay, so we have this. Now let's go into the editor. And over here on the camera controller, let's drag the reference, all right. So now here in the code, you would guess that maybe you could go inside this and find some kind of follow offset. Except, nope, there's no such thing. The only one we can see is the follow. And the follow is over here on the Cinemachine virtual camera. It's up here, the follow. So this is the only field we can find. We cannot find the one that is inside the body of follow offset. We cannot see this one. So we need to figure out how to change this value through code. And thankfully, Cinemachine also has all of the source code available. So if you just right click on the component and you click on edit script, this takes you directly to the Cinemachine code. Now if it doesn't, you can manually find the script. So go into your project window and then scroll down until you see the packages. And again, remember the thing I mentioned in the beginning, this little toggle button with the eye icon. If it's like this and you expand the packages, then you don't see anything. But if you untick it, yep, now you see all the packages. So like we were looking for, Cinemachine, so let's go inside the Cinemachine folder. And then you can browse around in here. And this one, I believe it's under runtime. Then under behaviors. And down here is the Cinemachine virtual camera. So again, here is that script. And now here again, we can try to see if it exists here. So if we search for follow offset, and nope, no results, can't find anything. But if you browse around this code, you can get some hints. If you look at it, you'll notice that Cinemachine appears to be based on some kind of Cinemachine components. And then there's this function where you can get a Cinemachine component where you just need to pass in the type of component you want. Then if again you expand upon the Cinemachine package, if you see, here's a folder called components, and if you expand it, you see all of these. And if you notice, if you go into the virtual camera, you can see the names of the scripts here do match up all of the various types that we have here. So for example, here we have a third-person follow, framing transposer. So all of the components are here, and the one that we're using is the transposer, which is the one down here. And if we open up this script, Then here, let's try finding an offset. And yep, here it is. We have our follow offset. So this is the exact field that we need to change. So with this, we now know what we need to do. So let's go back into our camera controller script. So we have the virtual camera. Now in the virtual camera, let's first get the CineMachine component of that type. So get CineMachine component of type CineMachine transposer. Okay, so now all we need to do is change the CineMachine transposer dot follow offset. So the m underscore follow offset. This one, as we can see, it's a vector 3. So just for testing, let's change this inside an if, just to test and see that it is indeed working. So let's do a mouse scroll delta. So if we scroll just in one direction, then let's set it to a certain value. So let's say new vector 3, 0, maybe 1, and minus 10. And here we want to test mouse scroll delta dot y. Okay, so let's test and see if we zoom in, if it does indeed modify the follow offset. So let's see. Okay, so here we are and the camera is perfectly normal. Now as I move the scroll wheel, and yep, there you go, it does indeed zoom in. All right, awesome. So with this working, now all we need is to use some logic and some proper values. Let's refactor this code to only access the CineMachine transposer once. So let's check for this and this. Then up here, let's define a vector 3 for the follow offset. And by default, let's use the one that is currently being used. Then if we have our input, and here we're going to modify it, and in the end we're going to set it again. Now when we have a scroll on the positive, when we do this, we want to zoom in. So let's go into the follow offset and modify the y. In order to zoom in, let's do minus equals, and let's do it by a certain float zoom amount. So up here, minus equals that zoom amount. Also, by the way, the reason why I'm not using time.delta here, the reason is because the mouse scroll delta pretty much works like a get key down and not a get key, meaning as soon as you move the scroll wheel just 1 unit, then that acts as just 1 unit, as opposed to being nice and smooth and constantly being held down. So that is why here we're not going to be using delta time. And then for the opposite, so if the scroll delta y is under 0, if so, then let's increase by the zoom amount. Okay, so just like this, it should be working. But we should probably also add some limits, otherwise the player won't be able to zoom in way too much or zoom out by a massive amount. And for some limits, let's define them as constants. So let's go into the top of the file, and up here let's make a private const to make it a constant, make it a float for the min follow y offset. And for the minimum zoom, let's say 2, and make one for the maximum, so the max follow y offset. And for the max, let's say 12. Then back down here into our code, we modify the follow offset. Okay, then before we assign it, let's validate it. So let's grab the follow offset.y and use mathf.clamp. So what this does is it takes a value, then a minimum and a maximum, and ensures that the value stays within those ranges. So for the value, let's use the current one, so follow offset.y. Then for the minimum, let's use our constant, and same thing for the maximum. All right, so that's it. So we get the CineMachine transposer. We grab the current follow offset, then if the scroll delta is zooming in or out, we modify the follow offset y, then you use a clamp in order to make sure it stays within valid values, and finally we upload the final value onto the follow offset. Okay, so with this, let's test. Alright, so as I scroll forward, yep, it does indeed zoom in. Now I scroll back and it does zoom out. And if I zoom in way too much, okay, this is the maximum, zoom out way too much, and yep, this is the maximum. Alright, great. Now, obviously, one quick note here, if here you have the opposite behavior of what you want, so basically if by pushing the scroll wheel forward, you want it to zoom out instead of in, so that's kind of a personal preference thing for me, I like it like this, but if you prefer the opposite, then it's very simple, just over here swap out the value. So on this one do a plus, and on this one do a minus. So if you prefer inverted, then go ahead and do this. For me, I like the way it is previously, okay. So with this, we have the zoom fully working, but it is way too snappy. We can make this nice and smooth by using a basic lerp, exactly like we did for the unit rotation, so doing that is going to be your challenge. Okay, so go ahead and add smoothing to the zoom, and as I mentioned, for a hint, go ahead and refer to the unit rotation to figure out how to handle lerp. It's pretty much exactly the same logic. Alright, so go ahead, pause the video and give that a go. Okay, welcome back. So let's add smoothing to our zoom. Like I said, it's going to be just like the rotation smoothing. So let's refer back to that script. So let's find the unit script. Here it is. Let's see where we're handling our rotation. So here it is where we set the transform.forward. We're using vector3.lerp. This one, if you remember, takes an a, b, and a time value. So for the starting, it is the current place. Then for the final, it is the final one we want. And then time.time, just multiplied by a certain speed. So as you can see, super simple to use. So let's go into our camera controller. Okay, so here we want to apply the lerp when we apply the follow offset to the Cinemachine transposer. However, right now we're using the follow offset, we're reading it here and applying it here. If we want to handle some smoothing, then we need to keep the target value over time. So instead of defining it here, we need to define it up here. So let's define a private vector3 for the target follow offset. And on start, let's make sure we get the current one from the camera. So private void start. So on start, let's get it, which means we also need to get this line. So we need to get the Cinemachine transposer. So we get it, and then we set the target follow offset based on this one, dot follow offset. And like this, we're also going to need the Cinemachine transposer down here. So let's actually make it a field variable. So let's make a private, store it, and over here, let's save it. All right. So we have our Cinemachine transposer and the target follow offset. Then let's go down into our zoom. And instead of using this follow offset, let's get rid of this, and we're going to modify the target follow offset. Okay, so we increase or decrease it. Then we also clamp it to make sure that it stays within valid ranges. And finally, for setting it, again, we're not going to set it directly, so let's use vector3.lerp, just like we saw. For the A, let's use the current one, so that's the Cinemachine transposer.follow offset, so that's the current one. For the B, that is our target, so the target follow offset. And finally, for the time, it's time.delta time multiplied by a certain zoom speed. Let's just define the zoom speed. So up here, let's make a float for the zoom speed, and let's say 5. Again, like I mentioned, the rotation, despite the fact that this says that it linearly interpolates, the way that we're using here is not actually linear. It's going to act like an ease out, but that's exactly what I want. Personally, I find that much more smooth, much more interesting. But again, just wanted to point out because the function says lerp, but we're making an ease out and not linear. All right, so with this, everything should be working. So let's test. So here we are, and if I zoom in, and yep, there you go, nice and smooth, and zoom out, and yep, also nice and smooth. All right, great. So everything works perfectly. Now, if you want, you can go ahead and play around the zoom amount and the zoom speed, but for me, these values work pretty great. Okay, so all logic is working. We've got zoom, we've got rotation, and we have movement. But before we end this lecture, let's actually refactor this code. We've got way too many lines of code over here in our update, and we're actually doing 3 completely separate things. So we're handling movement, then handling rotation, and finally handling the zoom. So let's clean up this code. Let's start off by getting rid of the debug.log. We no longer need this. And let's put all 3 of these things in separate functions. So we're going to have a private void handle movement, then a private void handle rotation, and finally a private void handle zoom. Also, if you want, you can use the Visual Studio Lightbulb to extract the method, but I prefer doing it manually, so let's do that. Okay, let's just copy our code. So all of our zoom, let's copy it and paste it down here. For the rotation, that is all of this, so let's copy it and paste it down here. And finally for the movement, it's all of this, copy it and paste it down here. Then update, we just call our functions, so handle the movement, then handle the rotation, and finally handle the zoom. Alright, so with this the code is much cleaner, much easier to understand. And with this we have our camera system fully working. So we can move in any direction, we can rotate the camera around, and we can also zoom in and zoom out. So we have all of the controls to be able to place our camera anywhere and view our world from any angle.